Example problem 2 reads, if a 4-liter container of helium gas has a pressure of 10 atm, what pressure does the gas exert if the volume is increased to 6 liters? So what's really important with Charles' law, Boyle's law, and Gay-Lussac's law, what's really going to help you figure out if you're using one of those 3 laws, is if you see that a condition has changed. So here you can see that a condition has changed. The volume has increased. So you have a set of 1 variables, something changes, and that results in a set of different variables, of new variables. The equation that I want you guys to use when you're trying to figure out which of the 3 laws to use is called the combined gas law equation. And that is P1 V1 over T1 equals P2 V2 over T2. And I want you guys to measure pressure and units of atm, volume in units of liters, and temperature in units of kelvins for all of these problems. You can use different units of measurement for pressure in these problems, but I prefer that you guys convert to atm because when we get to the ideal gas law, you have to be in units of atm because of the gas law constant. And so if you get that practice now, it's just going to be easier and already reinforced on the back end when you get to the end of chapter 18. So that being said, the reason why I want you guys to use the combined gas law is because you've got all 3 of the equations in one simple equation here, and you just cancel the variable that you don't need. So rereading the problem, we have an initial volume and we have an initial pressure. So our V1 is 4 liters and our P1 is 10 atm. And so those are in the appropriate units for volume and pressure that I want you guys to use. So we know that the condition changed here, which means we're going to have a set of 2's, a V2 and a P2. It's asking us what the pressure is, so we know we're going to be looking for P2, and it told us that the volume increased to 6 liters. And so the one variable in the combined gas law equation that's not present is temperature. So you can go ahead and just cancel temperature out and you end up with P1 V1 equals P2 V2, which you can see is exactly what Boyle's law is on the previous slide. So instead of having to memorize 3 equations, you just learn 1 and learn to work with that 1, which is much simpler than learning all 3 separately. So writing in what we know, 4 liters times 10 atm equals 6 liters times x, or P2, whichever variable you prefer to put. So to isolate x, we have to divide by 6 liters. You can see where liters cancels and we're left in atm for pressure. So in your calculator, 10 times 4 divided by 6 equals 6.66 bar, or 6.67 atm. And that is going to equal your P2. So let me know if you have any questions about example problem 2.